Kata is basically a live demonstration of programming, and the intent is to practice so much that, that the kind of programming you're trying to learn becomes reflexive. So what we've been doing is test-driven development katas to practice test-driven development, and all that basically.
Cool. So kata that I decided to do today, it's based on something that you would have to run into, if you're having to implement low-level protocols. It's basically taking chunks of data and separating into the proper frames of data. And I picked a really simple protocol to demonstrate this with. It's in the MIDI format, musical instrument digital interface. There's a type of message called a system exclusive message, which is specific to each manufacturer, and it's designed in such a way that any other manufacturer can recognize that it is that's called a sysx message without having to know what it is. But it's really simple because there is a particular byte that starts the message and a particular byte that ends the message. So you look at that start byte and that end byte, and everything in between is the message. So I'm going to implement that routine of just breaking that up into recognizing those messages. All right. So I've got an empty project here, and I'm going to start out. I'm going to call my method messages, and start out with a subject here.
Excuse me, can you make that larger?
Really? You can't see it?
It's a little small.
Okay.
Thanks.
Is that good? All right. So let me make this bigger too. Okay. So the first one thing I want to check is if there's no data, I should get no messages. So set up context with no data, and then it returns just an empty array. So expect. So I'm expecting the messages to just return an empty array. And of course it's going to fail because I haven't even implemented it yet. So our message here is undefined method messages. So you always want to, when you have a failure or an error, you want to either change the message or make it pass. In this case, we want to change the message. So we need to define the messages method. So now we've changed the message to a failed expectation. We got nil, we expected an empty array, so we can make that pass by just returning an empty array. So that's the red, that was the red and the green. Okay, now the next red with a single frame of data. So here we need to set up a single frame of data. So I'm going to make up a method called data, and so F0 is the start byte, and then we'll just put some random, well, not really random data in here, but and then F7 is the end byte, and we should get the contents out. So we want, in this case, messages equal a single array with the content of that frame. And of course, we're going to get some more errors here. So we need to change this message. Instead of we've got undefined data, we can change that message by defining data. Now we have wrong number of arguments, so we're going to change that message by defining our argument there in bytes. And now we've got a failure because we're not actually putting anything into messages. Now here we have this interaction between data and messages, so we're going to have to store some state somewhere. So I'm actually going to make this test pending for now and refactor this a little bit. So I'm going to create an initializer. And messages, and just return that. run test should still pass. So now I'm going to bring this one back. And in data, I can just say, just take the, I just put the byte straight in there, but trim off the first and last character, or byte, first and last element. And it passes, and I already see an opportunity to refactor here because instead of this messages method here, I can just find a reader. And it works. Okay, next, let's do with 2 frames of data. So here we want to have this start byte and some data, and then an end byte, and then another start byte, and two arrays of contents. Okay, so here we expect our messages to return 2 separate arrays of data. And of course that's going to fail because we didn't stop processing the one frame at the stop byte and start processing another frame. So we need to actually start paying attention to that. So instead of just doing this array subscripting here, I'm going to actually, I think I actually need to start iterating through each byte in the array. So let's start by doing that. This is not going to be that anymore. And what we can do, we also are going to need to be accumulating our contents here. So, so what we can do here is if we see the end byte, we can add our current contents to the messages and then clear it out. So I can type. Otherwise, we can just well, let's go ahead and drive out another failure. Actually, just stick the byte in there. This isn't going to work because there's one additional problem we have. That's not what I expected it to be.
Go back. The FACC should be FB, right?
Oh yeah, B. Thank you. Okay, that's the failure I expected. So we actually want to say else if B doesn't equal start byte, maybe. All right, that works. Okay. All right. Next, one of the things about the sysx messages is you can have other types of MIDI messages, and in our case, we just want to ignore anything other than sysx messages. So if we have anything that I'll call noise, I put it in quotes because it's not necessarily noise; it's just something we don't care about. End of frame. So we have some. This is going to be almost exactly like the single frame example, but we're going to have something. We have a extra byte there in the front that we want to just ignore. And of course that doesn't work. We actually get that because we're not actually waiting for the start byte to start accumulating data. So now we have to keep track of whether we're in a frame or not. So we need another couple variable here. Initially it's going to be false. And actually, so if we see the start byte, then we're going to go into a frame. Otherwise, also if we see the stop byte, we're going to do what we're doing. Then, if frame, then we're going to accumulate combine. And it works.
When you do the @messages, take input from ACC, would you also set in frame back to false at that point?
No, because we don't have a test driving that out yet.
Okay.
You don't write code with the TDD process. You don't write code unless you have a failing test. So the next thing, why don't we drive out that exact? I think if we have noise between frames, it'll drive out that. So this would be 2 frames of data, but we've got some noise in the middle there. Now we're getting that noise in the second frame because, as Leo pointed out, we're never getting back out of the in-frame state. So now in here we have to say in-frame is false, and now that works. And it's starting to get a little ugly. I would normally start refactoring at this point, but I'm going to drive it out. I'm going to do at least one more test to drive it out a little further, and then we'll start refactoring. Because one of the things that we want to be able to do is the frames are not necessarily all going to come in at once. We could get part of a frame and then the rest of the frame, so we need to be able to handle that. So if we get with a frame in 2 chunks, call it it's the same as the single frame example, except frame, let's say the first half of the frame and then the second half of the frame. And of course that doesn't work because we're not keeping track of anything in between calls to data. So now what we need to do is actually move this stuff up and make these instance variables. And so refer to those as instance variables, refer to those as instance variables, and all right, it works. I'm trying to think, is there any?
Yeah.
What's that?
You have a spurious F7.
We're assuming that the data is good. That would be an interesting thing to add if I thought I had time. Doing pretty good. All right, so we've got a pretty well working implementation here, but this is actually kind of ugly. It would this would probably fly if it were C code, but in Ruby we don't. I see a lot of C functions that have exactly this sort of structure. But in Ruby, we don't like to have any. I actually don't like to have any more than like maybe 3 lines of code in a method. Although sometimes I have to, but certainly not this many, and certainly not this. When you see it going in and out, in and out, in and out, that's a sign that it's you need to break some stuff up.
Simply using landscape is a paradox.
I agree. Usually. Yes, it's a smell. It doesn't. That doesn't mean it's wrong.
Change it.
But it's, yeah, I agree. I definitely agree it's a smell. So I'm going to start by actually making this look a little bit worse. So part of the reason why it's actually even as compact as it is because I've kind of got some different things intertwined in there. Really, we've got 2 different states, in frame and out of frame, and what it does in the in-frame state versus the out-of-frame state are 2 separate things. So that really should be expressed in the logic. So the top level if should really be if in frame, and then it should be else. So if it's in a frame, then it really then we should just do, well, if it's in frame, then we need to check if B is our stop frame thing, then we need to say false. Actually, we need to do all of this, don't all of that. Otherwise accumulated. If it's out of frame, then if you see our start byte, then we just need to say in frame is true. And that should still pass. Okay. So it looks even worse. It gives us a chance to start refactoring this. So one of the things I like to do whenever I'm iterating, whenever my method is just an iteration and inside the block is a bunch of stuff, I like to just extract that part out. So I'm going to make a method called datum for just one byte. And we get to outdent that a little bit, which is small n. So like that. So that's a little bit better. Not much, but a little bit. And now we've got these two different blocks of in frame versus out of frame. So let's make a handle in frame and handle out of frame. And basically just move this stuff down. And we're unendenting a little more, which is a good sign. Broken anything yet. So now, what this actually shows us is that we've really got kind of a simple state machine here. We've got these two states, in frame and out of frame, and the behavior when it's in frame and the behavior when it's out of frame are kind of mutually exclusive. And we're starting to accumulate some private methods down here. That's telling me that these really want to be separate classes. So one of the, there's actually a design pattern designed exactly for this called the state pattern. So and I haven't really come up with a really good step-by-step way of doing this refactoring, but I can make it I can take a relatively small step here. So what we need is in frame and out of frame. So one of the tricky things with the state pattern is the state has to be able to tell the thing that it's being the state of how to transition to another state. So the way I usually do that is I just have the method that can possibly transition return the next state. So if it's transitioning, it returns a new state, otherwise it just returns itself. So how we're going to do this is we're going to define datum inside of in frame and out of frame. This is going to be creating new code smells by getting rid of old code smells. But so for in frame, basically we want this same behavior here. Except we don't want to set this variable here. We want to return. Oh, by the way, we need to be able to reference. We need a reference to these messages here. So this is one of the things I don't like about the state pattern is that you have to do something like this. Okay. And actually, we can initialize this here. And so here, if we see the end byte, we need to for in frame we see the end byte. The end byte we need to return new out of frame with our messages. Otherwise, we need to accumulate the thing and just return the same state. And then over in handle out of frame. So instead of in frame equals true, we need to return a new in frame. Otherwise, just return self. And I'm just going to save to make sure I have the syntax okay. And now what we need to do is take this stuff and just place it with the state. What? No, go away.
Right now. Right now.
Right now.
That is fun.
Windows is the same. So we start with out of frame.
Windows would make you reboot.
Well, now it'll tell you it's going to reboot in a couple of days. All right, and then for this, we need to say state equals state. Yes, thank you. And did I get that right?
Should work.
I got it right, okay. And then we don't need this stuff anymore. So it should work now. So we're getting somewhere. Is it better than it was before? I don't know. But we can do some refactoring here. We've got some common stuff here that we can try to pull up into the base class. So for one thing, in both cases, we're basically using this initializer. So let's start with that. Just do super there. And we can get rid of the initializer here. Okay. And what's left is this datum thing that's in both of these. It has kind of the same structure. It has this annoying thing where we have to remember to return self. But it's not quite the same, so let's see if we can make it look exactly the same so we can refactor it or have the same structure. So one of the things we can just sort of inline this. So that looks about the same. And the other thing we can do, we can actually make a method called accumulate that in the case of in frame does what it already does. And then in the case of out of frame, okay, how do I fix that?
Try to disconnect on the AirPlay.
Okay.
Are you on AirPlay? Right?
Yeah.
Yeah.
Should have updated.
Off of AirPlay.
Why can't we send it to the guy?
Another option would be that's much easier.
Should have done that update.
The Apple guy.
Yeah. There's a critical update to AirPlay. Do you want to install?
Apple guy. They like all the toys. Nope.
Give me more.
All right, everybody else get off the Wi-Fi.
I said 35. Somebody please.
Where's it at? How often do you check it?
My kids are the ones who follow me because I'm every time I'm in class.
I did. I reconnected it. Oh, there it is.
Has it changed?
So I didn't know.
Like literally, it was 5 minutes in between when they asked me.
All right, everybody. So that time it actually disconnected me.
Yeah, that's just also a lot of
Okay, we're good. We're good. All right, so probably missed what I did was I created this hack, this accumulate method here in both cases, but in out of frame it doesn't actually do anything, so it's safe to call that right there. And we're still passing. So now we can sort of do this sort of state transitioning thing, pull that up into a method and state that I'm going to call transition, and we need to pass the byte itself and then a condition. And basically the exact structure there is if condition yield, else accumulate it and return self. So we can change this to say transition B. Just do that in the case of transition, and then we do the same thing down here with transition B. And that's a little better. And then we can be clever and turn this all into one line by going condition, yield, else, which is probably too clever. But so what?
Make it self-tap, so you at least know what.
Okay, yeah. So what tap does is it performs a block for effect and then returns the original object. So this using tap here makes it so whatever we do in the block, we return self at the end. So that's about time for some questions. Is this better than it was before? I don't know. The state pattern.
I vote no, it's not better.
The state pattern's always been one of those. I should stand in front of the camera. The state pattern's always been one of those things where it's like I see a problem. I know I'll solve this with the state pattern, and now I have two problems. Yeah.
I'm pretty sure you fixed the bug I was hinting at, which maybe you could look at as accidentally adding the feature.
Oh, maybe I should have used that to drive out the. So you're saying when I restructure?
The question is, so how do you feel about that? So you kind of added a feature here by accident.
I think that was not strictly proper TTD because I should have driven that out.
You can also look at it as if you write your code in a better way, it will have fewer bugs or fewer.
There's certainly some truth to that. I've had experiences on software that I've been writing where I literally found some bugs and fixed them by just meeting code.
Yeah.
I had this code for some special cases that I realized was not a special case after all, deleted it and everything worked.
How do you feel about making the start and stop bytes constant?
I was just going to ask about
That's a
this
good
magic littered throughout the code.
Yeah, that would be a good one. So yes, start by 0, stop by 7. And I actually, so yeah, I think that's a good idea. I don't mind using actual constants here because this is defined by the MIDI specification, so it's like these aren't going to change.
Yes, we're only using one place. unless you count the tests. It's still nice to know what it is, though.
Yeah, it makes the code clear.
Why do I care if it's F7?
Right. Anyone else?
This thing kind of screams out to me to make a fiber that so you can have code that looks like it's reading the bytes synchronously.
Interesting.
Have you seen that? Or
I didn't think of that. I actually thought of like doing a follow-up kata in another session. So this was a very, very much mutable state sort of solution, and I thought of doing a different solution, which a functional solution, which
Large stasis on the inside.
yeah.
I mean, you're kind of partway there because you are returning new instances of in frame and out of frame as your primary transition returns. I think the only other decision that I would have made if I would have gone this way is you taught the state classes that each other exists, so they can return each other, right? Because they're both. They are siblings as children of the same parent class. That's not necessarily bad. But I think you could have achieved slightly cleaner code if, as sysx needed to